All right, so we're going to start Unit 4 today. Okay, Lesson 1 in Unit 4 is actually fairly short. And then on Thursday, we're going to first off go over the exam and then start the climatogram activity, the climate graph analysis activity, which will take Thursday and Friday. It's an in-class activity. My intention is that you finish it in class. I don't have to do it for homework, so that's why I'm giving you most of Thursday's class and all of Friday's short class to work on it so that you can get it done. And yeah, we're sitting pretty good right now in terms of time. This unit rarely takes me more than 10 days to teach, and we have more than that. So I think we'll get a few days for final exam review. Okay, like honestly right now I think we'll have enough that I'll be able to do one whole class for chemistry, one whole class for biology, one whole class for physics. Okay, that's kind of where we're sitting. So we'll get a lot of kind of in-class final exam review.
Will we have a unit exam for Unit 4?
Oh yeah, yeah, and that's also a big opportunity to raise your exam mark because this is such a short unit. There's actually not that much on the test, so you can study it really well and know it really well. It's nice right before the final exam to get kind of this easier unit exam to boost your mark a little bit. Okay. All right, so we're going to go over climate today. We're going to look at a couple of things. First off, the components of climate. Okay, so that is what things make up climate. And then factors affecting climate. So that's stuff like the things that can make the weather in a place the way it is. Okay, and looking at the inputs and outputs for various environments. What's the basically major energy input for almost all ecosystems on Earth? Yeah, the sun and photosynthesis. Okay, very few ecosystems on Earth do not rely on the sun as their input energy, and those would be mostly like the deep sea kind of volcanic vents, tube worm kind of things. Okay, where sun doesn't penetrate. And then we're going to look at what climatograms or climate graphs are, how they work, okay, how to read them, so that we can do our activity on Thursday. Okay, so what do you suppose the components of climate would be? Like if you look at the weather in the morning, what are the 4 things that are most important? Temperature. Okay. Okay, humidity. Yeah, it's pretty important. Not a component of climate, but kind of part of one of them. What else do you want to know before you leave?
Precipitation.
Yeah, is it going to rain? Or snow? Or hail? Or any of the other things we get? Wind? Especially around here. Kind of tips things over. This is one you might not always look at. I always look at it. It's actually on the first page of the weather app. Okay, and it changes throughout the year. We're approaching the most of it.
Sun coverage?
Yeah, the amount of light. And light could be just how much light, how long the day is going to be, or whether it's going to be cloudy and we're not going to get as much direct sun, things like that. Okay, those are your 4 major components of climate. Okay, if we're just describing the climate of Okotoks, okay, what would we say the temperature is like? What did I get? Gross. Well, some parts of the year it certainly is. Okay. When I describe the climate of an area, do I want to describe like an average temperature, or do I want to describe what it does all year, like kind of how it changes? Yeah, I want to describe the pattern of temperature, because if I describe Okotoks as an average, like its climate as an average, then I'm going to say that the climate in Okotoks is that the average temperature is 6 degrees Celsius. Okay, that the precipitation is about 0.2 millimeters per day, and the wind is steady at about 25 kilometers an hour out of the southwest, and that we get 12 hours of daylight and 12 hours of night. Does that really reflect what the climate of Okotoks is like? Especially the light part. I could say that for anywhere on Earth. Okay, so instead, we would probably describe it like the temperature varies quite drastically in Okotoks as per the seasons. Okay, we get cold winters, we get warm summers, we get these two like violent transitions that we kind of refer to as spring and fall but aren't really. Okay, we get those. Okay, that would be, you know, temperature obviously fluctuates. Okay, and it can vary even strongly within a 12-hour period. Okay, here, right? We can get quick temperature shifts, especially in the winter time. For precipitation, I would probably say that we get a lot of our precipitation in the winter months. I say a lot, but it's probably not a lot. It's more like a third, okay, in the winter months as snow. Okay, the wettest month, what do you suppose our wettest month is? June, yeah. June is by far the wettest month here, right? June and July are the wettest months, but June is the wettest, and it is significantly. The bulk of our precipitation comes in June, okay? That's why when we get flooding, it's always in June. Okay, runoff is coming and the rains are coming, okay? It's the wettest month by far. Wind patterns, my description of the average is actually pretty good. Okay, most of the time the wind is out of the southwest at about 25 kilometers an hour. Okay, can it get colder or can it get stronger than that? Absolutely. Winds can be up to hurricane force here sometimes. Okay, and other times it can be calm. This weekend was really weird. It really wasn't windy at all. Okay, I was down in Pincher Creek for 2 days and it's always windy. The windmills were barely turning. Okay, it was odd. Okay, but most of the time, the wind is out of the southwest here. Okay, do we get wind out of the north sometimes? Nope, we did last week, and that's when it gets crappy. Okay, nothing good comes from that direction when the wind is coming that direction.
My neighbor had a small tornado go through their yard.
Like a dust devil?
But it was massive. Like he had a huge Quonset, that just fell on his own poles in the tent and it flipped over and he had like a small play set and it just like crumpled down on
This
itself.
weekend? Was it yesterday?
Yeah.
Had the same thing happen in my backyard. Out on the deck, umbrella up. Umbrella's not even moving, which is rare. Okay? And then all of a sudden, my wife's yelling, "Help!" And I look over and she's holding the umbrella that has 200 pounds of sand supposedly holding it down onto the deck. And it's trying to go. And it just came up out of nowhere. Just this whirlwind just came and just about took the umbrella. And my wife, that would have been very bad. Okay, it's been like the whole Wizard of Oz thing going on. Yeah. Okay, and then light. Obviously, our light here also fluctuates. Okay, we're approaching the summer solstice where we get over 18 hours of daylight. Okay, but of course on the summer solstice we get like 6. Okay, so yeah, our amount of light is greatest in the summertime and lowest in the wintertime. It fluctuates. We have to describe the pattern. Okay, and the long-term pattern of weather. That's what climate is. Okay, it's the prevailing weather at a location. Okay, so that's the definition of climate. The prevailing weather patterns at a location. Okay, our description, pretty accurate. Okay, the one thing we would have to say about our climate though is that it can also be quite variable. Okay, and that could be over the long term and also over the short term. Okay, I mean, Leonardo DiCaprio went crying home, okay, because he saw a Chinook happen. Okay, he was terrified. He actually said that. The warm winds of Alberta, okay, like they were terrifying. I was like, dude, chill. It's called Chinook, happens all the time. Okay? But yeah, it went from like -20 to +20 in a couple of hours, you know, like it always does when we get a Chinook. He was like, that's climate change. Climate change happens over thousands of years, not over 120 minutes. That's called weather. So, yeah. Sometimes people don't know what they're talking about, like that time. I bash Leo DiCaprio all the time because of that. All right, so when we have weather, okay, weather is basically changes in these four components. Okay, so on a nice hot summer day in July, we might get one of these. What do we call that cloud? Besides bad news. It's a certain type. You remember your grade 5 science? It's a big long name. Starts with cumulo. Cumulonimbus. This is a thunderhead. Okay, this is when we get the big thunderstorms with the golf ball size hail that put dents and everything. It looks like somebody went out your car with a ball peen hammer. Okay, yeah, we get these because of an interaction of all these factors. A day when we typically get a thunderstorm, we are going to have fairly hot temperature, fairly high humidity, little wind, okay, and that helps to build, okay, this, and we obviously have to have a fair amount of light energy coming in. It's usually, it starts out usually as a sunny day, okay? So all of those factors start this cycle going. And what happens is water evaporates from the ground and it goes up in the air because hot air rises, okay? Now, that air, because it's full of moisture, is actually quite heavy, okay? And as it goes up, it cools, and the water vapor that's in it does what? What happens when you cool water vapor? Before it freezes. Goes from gas back to liquid. Okay, so it condenses, and it actually, so it does this, it condenses, and it tries to fall back down. That's what rain is. Okay, rain is just water vapor that's condensed and now falls back to earth. The problem is on a day like this, there's so much hot, moist, heavy air moving upwards that these raindrops don't get to fall. They get pushed back up into the cloud, along with all the moisture that was pushing them there, and the raindrops get bigger. Okay? If you ever notice, like if we don't get hail out of a thunderstorm, it's usually really big, heavy rain. Okay, really big drops. Okay? That's because these raindrops have gone through this cycle in the cloud a number of times. Now, if it's an exceptional day, that cycle can happen enough that those raindrops get so high up in the clouds that they're above they're at an altitude where the temperature is below freezing. Okay? And then what happens is that water droplet freezes and becomes a hailstone. On an exceptional day, that hailstone tries to fall back down, but there's so much warm, moist air pushing that it sends it back up. Okay? So now this hailstone, this solid chunk of ice, is getting pushed back up, and it's surrounded by moist air. And when that air gets above the freezing point, then that water vapor condenses onto the outside of the existing hailstone, making it bigger and bigger. Okay? Next time it hails, wait till the hail stops. Then go outside and grab a hailstone and just give it a little smack with the hammer. It looks like an onion. It has layers. Okay? Those layers are like tree rings. It can tell you how many times it's gone up through the cloud, okay, and how many times ice or moisture has been deposited on the outside of it. If you got one the size of a golf ball, okay, it'll have a number of different layers in it. Okay? The more times they go through, the bigger they get. So when we get the little pellets, they've gone through once or twice. Okay? You get, the ones that are the size of a dime, okay, those have probably gone through 5 or 6 times. You get one that's got the size of a golf ball. It's probably done that cycle 10 times. Okay, they get pretty big. Years ago, they got a hailstorm in central Alberta where they had baseball size hail, okay, softball size hail. Occasionally, you get ice cream pail size. Those are pretty rare. Okay? But the largest hailstone ever recovered, when melted, held 4 liters of water. That's 1 gallon. That's an ice cream pail. Okay, so that's a lot. You wouldn't want to be under that one. Okay, I think it actually put a hole in somebody's roof. That's how they recovered it. But okay, yeah. When they get big like that, it's dangerous. Okay, and there were like car dealerships in central Alberta where they they wrote off their entire inventory. You ever notice that all the car dealerships around here have a hail shelter now? Because they won't insure them. Like, insurance is like crazy expensive. It was cheaper to build the hail nets, okay, to protect their cars from the hail. Of course, now they have no inventory because of COVID, you got nothing to protect with it. But whatever, it was there, okay, and it protects their inventory. All right, is that making some sense? Okay, so it's always, whatever weather we experience is always some combination of those four components. Okay, so you definitely need to know the components. That's an easy multiple choice question. Okay, it's also something that I would incorporate into written response questions on the UNP final exam. Okay, factors that affect your climate. What makes the climate in an area the way it is? Okay, the number one factor, and you could list this no matter what place on Earth you were talking about, is latitude. How far from the equator you are is the single biggest factor affecting your climate. The closer to the equator you are, the warmer it's going to be. Okay? The further from the equator you are, the colder it's going to be. Now, why is that?
Because the sun is technically closer to you, and it's having a lot more, like light is having a lot more direct path, and it has a lot less interference when it gets there.
Yeah, it's the direct path part, actually. It's the intensity of the sun. It's not so much that we're closer. Like, certainly the Earth is round. The Earth's round. If there's any flat earthers in here, you can just leave now. You're going to hate everything I say. The Earth is round. It's not a donut. It's not flat. It's not any other crazy idea. It's round. Okay? So, when the sun is shining on it, the stuff that's near the equator is directly under the sun. Okay? The sun is directly overhead at the equator, and so the sun is much more intense there. Okay? As you move away from the equator, this amount of sunlight, okay, because all of these bars are the same width, okay, this amount of sunlight, instead of hitting directly on the Earth's surface like this, is now spread out over a larger area. Okay, see how my line no longer touches the two edges? Okay, and it gets even worse as you go further north. Okay, that same amount of sunlight is now hitting a broader area, so it's less concentrated and less direct. Okay, everybody follow me there? Okay, now this particular alignment of the Earth happens how many days a year? 2. Spring equinox and the fall equinox. So the only 2 days of the year where the Earth is essentially straight up and down. Right? Because the Earth is tilted. And not just a little, 23.5 degrees. Okay? That's like more than 1/4 of the way off vertical. Okay? So it's tilted a lot.
Doesn't it shift?
And yeah, it goes back and forth. Yeah. Like, I shouldn't say it goes back and forth. Let me say it like this, with a terrible drawing. That's the sun. I'll label it just because my drawing is bad. Okay, that's the sun. Okay, now when the Earth goes around the sun in its orbit, okay, on March 21st and September 21st, the Earth looks like this. Okay, and its axis is straight up and down, and it's pointed at the sun. Actually, you know what? I should put those here and here, because it's easier to show what I want on the sides. Okay. On December 21st, the Earth's axis looks like this. Okay? And we are tilted away from the sun. Right? So the sun's light only hits like this. So it only hits this face, which is why in the southern hemisphere, they're getting summer and their longest day, and us in the northern hemisphere are tilted away and getting our shortest day, because when the Earth rotates, it rotates like this around its axis. So we spend the bulk of the time in the darkness on the dark side. Okay? And we only get into the light for 6 hours. Whereas on this side, the Earth's spinning like this, okay? They spend a lot more time. If you're on Antarctica, you get no nighttime. Okay? Now,
for June 21st, which is what's approaching, see, Earth's still tilted the same way, right? It's still tilted 23.5 degrees, but now the North Pole is pointed towards the sun. So now when the Earth rotates around on its axis, okay, we spend a lot more time in the sun than in the darkness, because this part of the Earth stays in the sun more. That's why in the north, the sun never sets. Okay, in Alaska, the land of the midnight sun. Okay, you don't. It's really weird. If you're in above the Arctic Circle on the longest day of the year, the sun just does this. It goes in a circle above you. Okay, doesn't set, but goes in a circle. Okay? It's really weird. All right, is that making some sense?
How does it go from a 23-degree angle to straight?
It doesn't actually get straight per se. It's just that at certain points in the orbit, we're not tilted. Like, so here, we're still tilted like this, but the tilt is perpendicular to the sun now, so it doesn't matter.
Oh, so it's like if the sun was here, then it's tilted like this.
Yeah, so here, like the Earth stays at that tilt, and so I shouldn't have drawn it like this. I should have drawn it. It's just when it's here and the Earth is doing this, the sun is going on to the side. So it doesn't, the tilt of the Earth doesn't make any difference at those two positions. Yeah? Okay? So the further you are from the equator, the colder it's generally going to be. And the more your length of day changes. Okay? So if you are here, where these two dotted lines are, okay, these two dotted lines are the lines that denote the tropics. Okay? The north one is the Tropic of Cancer, the south one is the Tropic of Capricorn. I'll never ask you that. Okay? Those two lines are 23.5 degrees latitude from the equator. Okay? Which basically means their length of day effectively doesn't change. Okay? Because the Earth's tilt, doing this back and forth, has no effect if you're less than 23.5 degrees from the equator. Okay? Making sense? The further you get from the equator, the bigger the effect it has. All right. This is also why you never see tropical rainforest, really, above or below those two lines. Okay? They require a certain amount of sunlight. Okay? All of your tropical climates are going to be between those two lines. Yeah? Everybody's good with that? Okay, so latitude, single largest factor affecting climate. So here's how I'm going to ask this on a test. I'll give you a map of like Canada, okay, and I'll pick a city and I'll point it out, right? And I'm going to ask you, tell me what factors most affect the climate of this city. Could you list latitude? Yes, you should, in fact, list latitude. It wouldn't matter if I said Tuktoyaktuk or I said Buenos Aires, Argentina. List latitude because it does. It affects no matter where you are. Further from the equator, colder it's going to be. Okay? All right. Altitude. Altitude affects climate. We see it all the time. There's no snow here, but there's still snow in the mountains. Okay? Do they get a little bit more snow than us? Probably. But it's also that it's still colder there. Okay? On average, for every 1,000 meters altitude you gain, it will get about 6 degrees cooler on average. Okay? We here are at 1,100 meters, okay, above sea level, right here. Okay, it's actually 1,096, but it's okay, above sea level. That means it's going to be noticeably colder here than it would be if we were in, say, Vancouver. Okay, now there's other factors, obviously, make Vancouver warmer than here, okay, but altitude is a big one. And we can see it. Snow stays in the tops of the mountains longer than it does here.
Who measured that we were that high above sea level? Because there's no sea around us to like be able to measure.
I don't know how they measure it. We're definitely, I mean, we're in the foothills, right? Like, you know, we're not near an ocean, you're right, but we're also way above sea level. Yeah. So if you like went straight out to Vancouver, like didn't like follow the curvature, like you would be looking down from a kilometer up. Yeah, be crazy. All right, so, and that's also why, like, if you go in the mountains in the summertime, you can actually see this. You can see, you know, if you're down, you know, in a valley, it's warmer, there's no snow, okay? But as you go up in altitude, you can start to encounter snow, okay? This is actually a picture that I took. I was on a hiking trip. And we started down at about, I want to say it was about 1,600 meters, okay? And it was about 10 degrees Celsius and it was raining. And as we came up in altitude to here, this was about 2,200, 2,300 meters. It was just starting to change to snow, okay? Up on top, this is Mount Robson, the highest peak in the Canadian Rockies, okay? And it is, I want to say it's 6,000 meters, something like that. It's quite a bit higher. There was a blizzard, it was -20. On the top of the mountain. All the same place, like all within a geographically similar area, okay? But the altitude made a huge difference, okay? And actually here, if you've ever gone to the Mount Robson area, you can actually see clouds just form, okay? You'll be able to see the peak, and then suddenly a cloud will form, and it'll go past, and when it's gone, it just, like, once it gets past the mountain, it disappears, the mountain's covered in fresh snow. Okay, even though it's sunny everywhere else, just because of how tall it is, it almost creates its own weather. All right, so altitude definitely affects climate. Is that one you could list for any city as well? Okay, like if I gave you, you know, Corner Brook, Newfoundland, which happens to be right on the ocean, okay, could you say altitude is a factor affecting its climate? You could. It's at sea level. Okay, if you went into, you know, the mountains of Newfoundland, into Grossmoor, and they have mountains that are pretty tall, okay, it would be a lot cooler at that altitude. Okay, so latitude and altitude are two factors affecting climate you can list no matter what city you're getting. Okay, Ethan, you had a question?
Would it be like the same, like 6.4, if you like went like that, like below sea level?
It's hard to get that much lower than sea level because the water will come in. There are very few places on Earth that are below sea level. New Orleans would be an example, and they have all the flooding problems, right? They get, you know, the hurricanes come in and, yeah. So there's very few places below sea level that are dry, because once you're below sea level, like, water always goes to the lowest place, right? There basically has to be something around that stops the ocean from coming in. But yes, theoretically, that rule would hold. Okay. All right. Distribution of land and sea. Vancouver and Calgary are the same latitude. They're obviously not the same altitude, but they're the same latitude. Okay? But Vancouver is always, I should say always, is often, especially in the wintertime, warmer than Calgary. And it's because it's right next to the ocean. Okay. Water has a very, very high heat capacity. What that means is that it can gain and lose a great deal of energy, but not change temperature very much. Okay? So the ocean acts like a big heat sink. And so when the air starts to chill and get cold, heat comes out of the ocean to warm the air because of the second law of thermodynamics. Okay, so energy always goes from hot to cold. Well, if the air gets cold, energy comes out of the ocean and warms the air. It's why it very rarely gets below freezing in Vancouver. If they get snow in Vancouver, like, the whole city shuts down. Okay, just because it's not something that they're used to. Okay. So being next to the ocean can regulate and moderate your temperature. Okay? Now, part of that is also the nature of the ocean currents that are going by. Okay? The ocean in Vancouver is warmer than the ocean in Newfoundland. Okay? It's still cold, but it's not as cold as the ocean in Newfoundland. okay? And that's because the ocean current that's going by the west coast of Canada, okay, is coming like kind of straight across and from like a lower latitude, okay? It goes up. They call it the subarctic current, subarctic, okay? Look at Newfoundland. Look at where the water that goes past Newfoundland is coming from. It's coming out of the Arctic, okay? That's why the ocean off of Newfoundland can actually freeze in the wintertime, okay? The place where my wife grew up, they had cove there, and it would freeze. So, well, not all the way to the bottom, but freeze solid on the top, okay? So yeah, it's much, much colder water because it's coming out of the Arctic. The Labrador current, okay, comes out of the Arctic, okay, and it actually interacts with the North Atlantic current, which is actually warm. It brings water from the tropics up. Okay. That's also what creates all the big storms that they get there. That's part of like the hurricane cycle and things like that that go on the East Coast. Okay. You ever notice that they never get a hurricane in Vancouver? They always get them on the East Coast. Right? Los Angeles never has a hurricane. Okay? Just ocean currents don't work that way there. All right, so distribution of land and sea. If you're close to the ocean, it's going to have a moderating effect on your climate. Okay? The ocean is also, obviously, a source of humidity, provided the wind is the right direction. Okay? And so you can get a lot of moisture in the air. Okay? I don't know if anyone's ever noticed this, but like you go from here to someplace closer to the ocean and suddenly your skin feels so much better. Okay? Just because there's so much more moisture in the air. Your sinuses feel better. Okay? All that kind of stuff. Okay? It's humidity, and the more moisture there is in the air means you're likely to have a lot more rainfall, provided again the wind direction is right. Okay? Right, and then the nature of ocean currents, so we got the Labrador current, subarctic current, and these two things which you've probably heard of. El Nino and La Ninia, okay? They are periodic ocean currents that actually originate off the coast of Argentina, okay, in South America, and when they happen, they can raise the global ocean temperature 2 degrees Celsius. Now, I know that doesn't seem like very much, but think of the volume of water involved. Okay, that's a great deal of energy, and that's when we can have those winters where like it's around Christmas, and, you know, we get a very mild winter. La Nina is the opposite. When the cold water comes up, the ocean temperature can drop 2 or 3 degrees, and we get one of those wicked long winters like we had in 2019. It was like minus 40 for 5 weeks. Okay, that kind of. All right, questions there?
How does that, like, how does El Nino and La Niña work?
You know what? I'm not terribly familiar with how they work. I know what they are. I don't know what makes the ocean, like that current, become more intense and less intense. That's what it is. It's just when it's more intense, we get an El Nino. It gets warm. When it's less intense, I guess water comes in from the Antarctic. Okay, it cycles differently, and that can change the temperature. I'm not sure what the mechanics of the cause of it are, but it's what happens. Don't know how it happens. Okay, if I ask you to describe the factors that affect Okotoks climate, this had better be on the list. The distribution of mountain barriers. Okay. We are in what is called the lee of the Rocky Mountains. Okay. Winds typically come from the southwest here. Okay. And that's because of where we are, latitude-wise. Okay. They have to go over the mountains to get here, which is why this part of Alberta, south central and southern Alberta, are typically very dry. Okay? Because air that's coming in from the ocean, okay, is full of moisture. It hits the Rockies and it's forced up. Okay? It can't go through them, so it's got to go up and over. And as it goes up, it cools. And all the moisture that's in it falls on what we call the windward side of the mountains, BC. Okay? That's why there's temperate rainforest on the west coast of BC. Right? Has anyone ever been to like Stanley Park? Right? They got the big giant redwoods, okay, all those big things. Have you ever seen Return of the Jedi? They filmed that outside of Vancouver where they all have all the big trees. Okay? The huge trees. There's actually one that they've cut a hole in it, you can drive an RV through it. Okay, like that's how big it is around. The big sequoias, it's crazy. Okay, we only get that if you get lots of moisture. So most of the moisture falls on the western side of the mountains. Okay, and then as it comes up and over the top, it's essentially become cold and dry. Okay, then it starts coming down on this side. Gravity accelerates it. Okay, because it's mass, it's air. Okay, so gravity accelerates this cool, dry air, and as it comes down the mountains, there's this. It's called a katabatic effect, and it makes it warm up. Obviously, because it's dropping in altitude, but also because it's kind of spinning down the side of the mountain, which generates some extra heat due to friction and things like that. Okay, so this air warms up as it comes down the mountains, and then comes off the mountains at a fairly high speed, fairly warm. What do we call that? The warm winds of Alberta that terrify Leonardo DiCaprio are called? That's how Chinook is born. Okay? That's where Chinooks come from. Okay? They are air that has gone over the mountains and then tumbled down our side, picking up speed, picking up energy, okay, in the form of like thermal energy as well, okay, and they come racing off the mountains, but they're dry. Okay? Because they're dry, they tend to pull moisture as opposed to give it, okay? Which is why it tends to be drier on the leeward side where we are than on the windward side. Okay? Lots of big deserts are actually what we call rain shadows. We're in the rain shadow of the Rocky Mountains. Same with Arizona and Utah and all of that kind of stuff. Emily, tell your friend to go away. Thanks. Okay? Does everyone kind of understand how that works? Okay, so lots of big deserts are because there's mountains between that area and the source of moisture. Okay, so you get this rain shadow. Behind the Himalayas is the Gobi Desert. Okay, the rain shadow desert just like here. All right, so that's a big one. Okay, so if I gave you basically anywhere in southern Alberta as a place to describe the climate of, mountain barriers would have to be on your list of factors that would affect the climate. All right, and the pattern of prevailing winds also can affect your climate. Okay, typically here, wind comes from the southwest, okay, which means that we have fairly stable weather. Okay, the wind's coming from that direction, we know what we're going to get. It's going to be warm and dry. Okay? When it doesn't come from that direction, obviously we can expect other things. Okay, so you got your pattern of prevailing winds. So the way that that works is, obviously most of the time, wind comes like this for us. Okay. Occasionally, we get wind coming from a different direction. Okay, and that's usually what's going to bring in like storms and things like that. So how many people have heard the term polar vortex? Okay, so there's bands of prevailing winds on Earth. We're right at the border between the kind of mid-latitude westerly winds, which is what we typically get, and the polar easterly winds. So at the pole, wind tends to cycle like this. Okay? And so they typically get wind coming from the east. When we get a polar vortex, that pattern descends much lower than normal. Okay? And they can even feel it down into the United States sometimes. Right? And so what's happening is we've got wind that's coming from the north that is dry. Okay? And it's interacting oftentimes with air that's coming from here. And this air is warmer and full of moisture. So when we get one of those wicked storms where we get tons and tons of snow, it's this warm, moist air interacting with this cold air. Where do they interact? Right down Highway 2. Okay? Same thing happens in the summertime. We don't get snow, we get big thunderstorms. Okay. That's what creates essentially the tornado alley of Alberta. Okay? The tornado alley of the central United States, okay, kind of in this area here, okay, same idea. Okay? There's air coming from different directions, okay, usually warm, moist air from the Gulf interacting with northerly air, causing your patterns of tornadoes in that area. And that's been shifted up recently because in Ontario, they're getting all these wicked storms and tornadoes, a bunch of people without power. And then centers of high and low pressure. I feel like a weatherman whenever I do this one. Okay, so I got my map, and what we have typically is right in here is typically high pressure. It's called the Siberian high. Okay, and over here we typically have low pressure. Okay? It's actually called the mother low because big low pressure areas that come to us usually come from there. Okay, now. Rotation around low pressure areas looks like this. It's clockwise. Okay? Rotation around high pressure areas is counterclockwise. And so stuff spins off of the low pressure area, stuff spins off the high pressure area, and they get channeled right down here. Again, that's what gets us our big storms, that's what gets us our hail and thunderstorms in the summertime. So if you're near one of those areas of high and low pressure, it can really affect your precipitation. Okay? This is typically cold and dry. This is one of the wettest areas in North America. Okay, like Fort St. John, Prince George, okay, those kind of places, their precipitation is massive compared to ours. Okay, they would get like over a meter of precipitation easily, sometimes even more than that in a year in these areas. Whereas here, we measure our precipitation in millimeters. Okay, it's that much smaller. Okay, give you guys a 5-minute break here, and then we'll talk about climatograms. Okay, so 9:35. We'll get back to this. So climate graphs don't show everything about an Earth. Okay, they show temperature and they show precipitation, but you can actually get quite a bit of information about an area from just those two pieces of the climate picture. So if I'm looking at this first climate graph, okay, or any climate graph, they have two parts. They have a bar graph and they have a line graph. So there's actually two different things being graphed on the same graph, temperature and precipitation. The line represents the temperature, and the bars show the precipitation. So there's actually two different y-axes. Okay? On one side, you've got rainfall, so your precipitation is on, not always, but sometimes on the left. Okay? And your temperature in degrees Celsius is on the right. Again, those can be switched, doesn't really matter. There's two things on the graph.
What is measuring precipitation residence?
Because this place is really wet. Okay? So the places that we're looking at here, you know, like if you're talking about monthly precipitation, centimeters isn't bad to use. Here we use millimeters just because we typically don't get more than about 70 millimeters in a month. Okay, like June we would get somewhere between 50 and 100 usually. Okay? And so that's only to 10, right, centimeters, so it's not huge. So here, where we're in a tropical rainforest in New Guinea, okay, like they measure their monthly rainfall, they get 35, well, sorry, not 35, but like 33 centimeters of rain in their wettest month. Okay, if we ever got that much rain in a month, like we would be all swimming. Okay, because it's just, that's a crazy amount of rain. Like the year we had the flood, so in 2013 when we had the big floods, that month we got 77 millimeters of rain. Now we got it in like 8 days or something like that, so it was a lot. Okay, but if we were ever to get that much, we'd be flooded. And a tropical rainforest is typically flooded a lot. Okay, these are areas where they build houses on stilts. Okay, you don't dig a basement in New Guinea. Okay, because it'll just be a swimming pool unless you want that. Okay, yeah, it's typically quite a bit wetter. Now, what we do notice about the temperature line there is that it's almost wet. It's almost perfectly flat. Okay, that's very typical of an equatorial climate because the intensity of the sunlight they receive is not affected by the Earth wobbling back and forth on its axis. Okay, so anything that's near the equator is typically going to have a very flat temperature pattern. This is Nashville, Tennessee, and this is Anchorage, Alaska. Once you get past about 30 degrees latitude, you start getting a noticeable bell curve shape to your climatogram. Okay, and what that means is now you have seasons. Okay, in New Guinea, they have the wet season and the dry season, but there's not really like a summer, a fall, winter, and spring because they're at the equator and it doesn't really change that much. Okay, but if you go to Nashville, Tennessee, okay, which is mid-latitude United States, then we have definite changes or patterns, okay, in the temperature. Okay, there's a summer for sure, and then there's a winter. Everybody follow me on that? So that's one of the things you can tell from a climatogram. Okay, is you can tell the latitude basically. Right? If you've got a bell curve, you know it's not equatorial. Where the bell curve is can help you determine how far from the equator it is. Okay? In Nashville, Tennessee, it rarely gets below 0 in the winter. It gets cool, but not really below 0. And in the summertime, it can be, high 20s. In Anchorage, Alaska, it gets quite a bit colder than that, right? In the wintertime, it's well below 0, and the summertime gets to be about 15 degrees. Okay? It's much further north. Okay? And Anchorage is one of the milder places in Alaska because it's actually on the coast. Okay? And the ocean helps to moderate the temperature quite a bit there. Okay? Now, if we look at the rainfall, okay, yeah, here in the rainforest, okay, near the equator and in the rainforest, we've got lots of rainfall and a dry season, dry season, and a wet season. In their dry season, they get more rain than we got in June of 2013. Right? That's their dry season. In Nashville, Tennessee, okay, it's much lower, but it's still fairly regular. Like there's 1 month here that's a little wetter, but right, it's generally pretty even. Okay? And that's a typical pattern for that part of the country, okay? Because they have a deciduous forest there and it requires fairly regular rainfall. Okay? If you look at Anchorage, Alaska, on the other hand, okay, Anchorage, Alaska is actually fairly dry, and much of its precipitation actually comes in late summer and early fall. Okay? That would be mostly snow, okay, at that point, but that's when it gets the bulk of its precipitation. The rest of the year, it's pretty dry. Okay? Everybody kind of following me on how to read those? Okay? Because what I always do on your test is I put a climatogram up there, and I say, interpret the climatogram, so basically do what I just did. The temperature changes, this is obviously fairly far north because the curve is down low, and the temperature is very low with, or the precipitation is fairly low with the bulk of it coming in the late fall. Okay, you get some marks for just being able to tell me what the graph says. And then I would ask you, where is it? Okay, and by where is it, I don't mean name a city. Later on in the unit, we're gonna learn about the different biomes, the tropical rainforest, the Arctic tundra, things like that, and I would ask you match it up with one of those. Okay, so that's what you'd be asked to do. Okay, so what would that look like? What if we were gonna make one for our area? For here in Okotoks. Okay. What would it look like? We'll put temperature over here. Okay, so let's do the temperature one first. We'll do it in green, and I should put a scale on here. Let's put 0 here, and
it's hard to explain, but I guess like for January, it would be like probably like -3
yeah.
around there.
I mean, we say -30. On average, it isn't -30, but yeah, it's cold. Yeah, we could probably put it like here.
And then like February, March, April, May, you might as well just draw squiggly lines.
Yeah, like a heartbeat, yeah. Okay. But I mean, generally, February should be a little warmer, okay? March is, trending upwards, okay? April, trending upwards to probably around 0. May, we'll get kind of here, okay? June, July, August, right? And then September is going to start to taper, okay? October, November, December. Okay. Did we get a bell curve? Okay, that's what we should get. Okay. We're looking at the climate of Okotoks. We're definitely pretty far from the equator, so we should have that shape for our climate graph. Okay, we just finished saying a little while ago that June is our wettest month, and I mean, if we're doing this in millimeters, obviously this would be 0, okay, wettest month. Let's put 100 up here, okay, we're never gonna get more than that in a month. June, we could probably put maybe about here, okay, that's our wettest month. How did that end up so far over? June's here. That's where June is. Okay, and then May would be a little less than that, so. Okay, and then March, okay, kind of maybe here. I didn't get April. April would go there. March would be kind of here, okay, because we get a fair amount of wet snow in March. February and January actually tend to be pretty dry months for us. We don't actually get a lot. Like we associate January and February, we get snow, but here's what you need to realize about snow. 10 centimeters of snow equals 1 centimeter of rain. Okay, so it's not much. Okay, we don't even get, like, we get rainfall warnings if we're gonna get more than 15 or 20 millimeters of rain. So 1.5 to 2 centimeters of rain. So when we get a big snowstorm, a wicked dump of 10 centimeters, or 20 centimeters, it actually doesn't represent a whole lot of moisture. Okay? It's inconvenient, we have to shovel it and it gets in the way, but it actually doesn't represent a huge amount of water. Okay? Because it's 10 to 1. Snow, when it falls and sits in piles, is full of air. Okay? It's kind of like styrofoam in that way. It's mostly air, so there's lots of it, but it's really light. Okay? In March, it's typically heavier and wetter, right? July would probably be something like this, maybe. August, okay, at least here, our rainfall tends to go down quite a bit. Okay? So what we typically see is that our temperature pattern and our precipitation pattern mimic each other. Okay? Generally. Everybody with me on that? Alright, I'm never going to ask you to build a climate graph, but I will have you interpret them. Okay, so I'll build one and give it to you, and you'll have to interpret it and tell me, okay, some stuff about it. So if you just saw that, not knowing that it was Okotoks, okay, you'd be able to tell me that it's probably not very close to the equator, probably closer to the pole than the equator, okay, and that it's actually relatively dry. Okay, the weird thing about climatograms is that you really have to watch the scale, just like any graph. Okay? This scale only goes up to 100 millimeters, so it makes Okotoks look like it's fairly wet because the precipitation bars would be big. Okay? But if I did it on this scale, Okotoks would look like this. It would be kind of probably even look, actually it's lower than that. I made that way too tall. Be more like this. Okay. It can be a lot less. Okay, the precipitation, I mean, not the temperature. Okay, we have way less rain than a place like this. Okay. Everybody with me there? All right. I would like you guys to write some answers for these 3 questions. I'll give you a few minutes and we'll go on repeat. Okay, so list the components of climate, describe them as you think they are in central Alberta. So that would be like Edmonton is central Alberta, okay? So probably for the temperature, okay, it would be obviously variable, okay, but leaning towards the colder side because it's quite far from the equator, okay? So colder winters, okay, moderate summers, okay, that kind of thing for temperature. For light, obviously also quite variable, short days in the winter, long days in the summer, okay, because of the, the distance from the equator. For rainfall, it's a bit more regular up there, okay? Their summer months tend to be more uniform as opposed to where we have June really wet and then it kind of falls off. It's a little bit more regular throughout the summer up there, and they get a bit more snow through the winter time. Okay? And for wind, their winds are going to be from many different directions, weather dependent, okay, but more typically from the northeast, okay, would be their typical wind direction, and not very strong. Okay? The winds in Edmonton are not very strong typically. All right, what factors would most affect the climate in our area? How? Okay, I'm thinking 3. What 3 am I thinking? Okay. Okay, latitude, Kai?
Distribution of
Mountain
mountain barriers.
barriers. Latitude, mountain barriers, I'm thinking one more. Altitude, yeah, those would be the big 3 for us. Okay, we're at almost 1,100 meters altitude, which is going to make it cooler and drier. Okay, we are obviously quite far from the equator. Okay, looking at, well, the 49th parallel is the border between Canada and the United States, so we're north of that, probably like 51 degrees, okay, something like that, so more than halfway. And then obviously for the mountain barriers, we're close to the Rockies and they block a lot of the moisture from coming across. Okay? Now, if we're describing the climate of Saudi Arabia, how would it be a lot different? What would we say the temperature is like there? Hot. Brutally, brutally hot. Okay? All year long. Okay? Because it's near the equator. It's also very dry. Okay? If you've ever been, if you like Dubai, it's basically the same place as Saudi Arabia. Okay, like they're right beside each other. So hot, dry, and regular all year long. Okay, that's what it's going to be like. There's not a lot of mountain barriers, but they are closer to the ocean. The problem is the wind blows the other way, and they don't get any moisture from it. Okay. All right, is that making sense? Okay. So for tomorrow, what time can you start? 10 after 8. Okay. Just bring your calculator and pencil. That's all you need to have. I'll take your phones in the bin, same as always, and then give you your test.